We want to look at this question related to conditional probability. We're told to find the probability that the family of two children has two boys, given that it has at least one. So let's first define our events. So let event X be the family has two boys, right? And let event Y be the family has at least one boy. So what we want is probability the family has two boys, i.e. the probability of X given that the family has at least one boy, i.e. X probability X given Y. So the first approach that we're going to use is we're going to use the formula of conditional probability to find this conditional probability. And based on the formula, the probability of X given Y is the probability of X and Y. Remember the comma means under intersection divided by probability of Y. So the probability of X and Y is essentially the probability the family has two boys and the family has at least one boy. Since it's a family of two children, probability of X and Y just simply means the family has two boys, right? Because we're finding the intersection of these two events, two boys, at least one boy. And for a family of two children, that just means the family has two boys, right? When we look at the intersection. So here it's like two boys and at least one boy, so the intersection would just be has two boys, right? So then a probability of Y is just the family has at least one boy, right? Because Y is the family has. So we want to find the probability the family has at least one boy. Remember, at least means greater than equal to one. Now let's see what these probabilities turn out to be. So we want to figure out what these probabilities are. For this, what we're going to do is let's look at our sample space. What is our sample space? It's a family of two children. So the sample space for the family of two children would be the first is a boy and the second is a boy. Or it could be, or all possible outcomes are the first is a boy, second is a girl. The first is a girl, the second is a boy, and then both are girls. Where all outcomes are equally likely, right? We're assuming that the probability that the girl is 50% and the probability that the boy is 50%, right? So we're drawing the sample space where all outcomes will be equally likely. The probability of a boy and girl are 50-50. All outcomes are equally likely. So this is important. So this assumption, so sample space is based on the assumption the probability that the girl is 50% and the probability that the boy will also be 50%. So now in the sample space, let's see what the event X intersection Y is. So X intersection Y is the family has two boys. So this event only has the outcome boy, boy. And what about Y? The event Y, event Y is the family has at least one boy. So this includes the outcomes. So this can have boy, boy, because at least one means greater than equal to one. So it could have one boy or two boys, right? So it could be boy, girl, and it could be girl, boy, right? So this event includes the following outcomes where you have at least one boy. Now over here, let's recall something. Let's recall. If all outcomes are equally likely, like we're assuming in this case there are, if all outcomes are equally likely in our sample space, in this case they are, again the key is are equally likely. Probability of A can be found as number of outcomes favorable to A divided by total number of outcomes in sample space. So in this case, because we have the assumption of equally likely outcomes, so we can find the probability of each of these events, X intersection Y and Y, by just seeing the number of outcomes in each of these events divided by total number of outcomes in the sample space, right? We can find a probability in this way. Remember, this formula probability only works when you have equally likely outcomes, which we have in this case. So probability of X intersection Y would be, so X intersection Y, the number of outcomes in X intersection Y are one, right? Because it only has one outcome, both are boys. So I have a total number of outcomes in sample space, 1, 2, 3, 4. So this is 1 divided by 4. Similarly, we can find probability Y. There's number of outcomes favorable to Y, which is 1, 2, 3, divided by total outcomes in sample space, which is 1, 2, 3, 4, right? So again, the reason we are able to find these probabilities using this is because we have equally likely outcomes. right? So in this way, this just turns out to be 1 by 3. So this is approach 1. Now let's do this exact same question using approach 2. Hmm. Approach 2 is we'll shrink the sample space instead of using the formula. What do we mean by this? We'll find the reduced sample space. Shrink the sample space. So what is the reduced sample space? So basically, we will remove what is not a possibility. So remove what is not a possibility. You shrink the sample space, find the reduced sample space. In this case, we are given, in this case, that the family has at least one boy. So we're given this, right? We're told that the family has at least one boy. We're told this given that it has at least one boy, right? Which is essentially the event y that we defined. So remove all outcomes. So you'll shrink the sample space, find the reduced sample space, move everything that's not a possibility, which will be remove all outcomes where there is no boy, because we're told there's at least one boy, right? So we'll remove what is not a possibility, which is that there is no boy. So the reduced sample space is just going to be, our original sample space was, remember, for this family of two children, boy, 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 girl, girl, boy, and girl, girl, right? This was a sample space, right? Now we're removing what is not a possibility, which is that there is no boy, which is that both are girls, right? Because we already told there's at least one boy, right? So in this reduced sample space is we're going to remove the outcome where both are girls, right? Because we're told that there's at least one boy. This is a reduced sample space, removing what is not a possibility. Now out of this reduced sample space, we can now see how many outcomes have both boys, right? Because you want to find the probability that there are two boys given that it has at least one boy. So we found the reduced sample space where we know this, where we've removed where we remove what is not a possibility. Now in this reduced sample space where we show that there's at least one boy, we want to find the probability there are two boys, right? So probability x given y. So in this reduced sample space where we have at least one boy, we want to find the probability that they're both boys, either probability of x given y, the probability of two boys given there's at least one boy. In this reduced sample space, we do know there's at least one boy. So let's find all the outcomes where they're both boys, which is one, right? So the probability of x given y would just be 1 divided by 3, because in this reduced sample space where there's at least one boy, there's only one outcome where you have both boys, right? So instead of using the formula, we're just shrinking the sample space by removing what is not a possibility. And in this reduced sample space, we're finding our required probability. So in this reduced sample space, we're seeing all those outcomes if both are boys. Right? So it's 1 divided by 3, the same answer. Just a warning here. We can only find probability of an event. We can only find probability of an event as number of outcomes favorable to the event. Favorable to the event divided by total number of outcomes in sample space. If we have equally likely outcomes in sample space, which we had in this case, if we had equally, which we had in this case, because of the assumption that the probability that it's a girl is the same as the probability that it's a boy, there's a 50-50 chance. We have equally likely outcomes. So remember, whenever you are using this formula to find probability, make sure you have equally likely outcomes in sample space. Otherwise, you cannot find probability as number of favorable outcomes by number of total possible outcomes. That only works under the assumption of equally likely outcomes. This is something to keep in mind in general.